Significant figures. The goals of this video are first to determine which numbers are significant, and then we need to know how to use them, how to complete multiplication and division, as well as addition and subtraction. We'll extend this then to include constants and how we work with different types of constants. First, let's decide how we know when something is significant. First, we'll walk through each of the rules, then I'll go back and discuss the sort of overarching theme here so that it's easier to remember. Anything that isn't a zero is significant. So for example, for 54, both are significant. There are two significant figures. Zeros are where things get more complicated. If you have a zero between two significant numbers, that's also significant. So anytime you have numbers, if there are zeros scattered in between, it is significant. So for here, we have 504. We have three significant figures. Now things start getting a bit more complicated. So I have zeros left of a non-zero digit aren't significant. So what does that mean? So the second example here is a little convoluted. It is an example of this situation, however, it isn't one that we see very often. The far more common example is this first one listed, 0.00504. Now we have these two zeros right here that are not significant. Here we have 504, three significant figures. For numbers over 1, when we have to the right of the decimal point, these are going to be significant. So if you had, 204.00, those to the right of the decimal point are significant. Trailing zeros are not significant. However, if you use a decimal point or scientific notation, they are. So what do we mean by trailing zeros? Something like 4,200. Now, let's look at the overarching theme here so that you're not memorizing all of these rules in a way that's going to be hard for you to remember. If we look at this 4,200, what would happen if we x'd out these zeros? If we got rid of those zeros, we took them away. Would 42 be the same number as 4,200? No, of course not, right? Very, very different numbers. You'd much rather have $4,000 than $400. Now, if we look at this number right here, what if we took away these two zeros? And we said 0.504. Well, same thing. Those are not the same numbers. 0.00504 is not the same thing as 0.504. So the zeros here and here are simply placeholders. They're zeros that are there to tell you what the number is. This is very different from the zero right here. This zero, if we were to erase all of the zeros and just leave it as 2, 2 is the same number as 2. So why have these zeros here? Why add this 0.000? That's for accuracy. That's to say that we can measure a very specific number, that if we're measuring something that's 2 centimeters long, that we can get to 2.000. It's not that you eyeballed it with a bad ruler that was about 2. As you measured it very, very specifically. And so these zeros, they serve no other purpose here than to show you how awesome you can measure. And so because of that, those are significant. Here, the purpose is as just a placeholder to show you that there's the same number. So that's the easiest way to remember these. Now, two more things with the trailing zeros. If you wanted to make both of these significant, you could put a period there. Be careful with the periods, they get forgotten about pretty easily. Usually my preferred method is to actually switch to scientific notation. Now here I gave you an example where you had to switch to scientific notation because having three significant figures would have been impossible. So let's say you were doing some sort of problem and you got 4,200 as an answer, but you needed three significant figures. If you just left it, well, that's only 2, so that would be wrong. If you put a period there, well, that would be 4, so that would be wrong too. So the only way to get the three sig figs is by switching to scientific notation. Because when we have scientific notation, all of them are going to be significant. So now we need to see what we're going to do if we need to actually work with these numbers by doing addition, subtraction, or multiplication and division. So first, let's start with addition and subtraction. In this case, we're going to use the lowest number of places. For instance, tenths or hundredths places, or tens or hundreds places, not significant figures. So here I have an example where we have 11.24 plus 0.345. Now, this has 4 significant figures, and this has 3 significant figures. So if we were going off significant figures, this wouldn't be the right answer, right? But since it's addition, we're going off places. So here we have the tenths, hundredths place. Here we go out to the thousandths place. So since this is the least number, we're going to want to go to that place. We're going to want to go to the hundredths place. So when we come here, we round this out to the hundredths place. The same sort of situation happens when we have no decimal points and we just have numbers. So here we have 111,300, where our lowest number of places is at our hundredth spot. And here we only really have one sig fig, but it's in the thousandths place. So since this is in the thousandths place and this is in the hundredths place, we're going to round to the thousandths place. For multiplication and division, we use the lowest number of significant figures now. So for example, if we have 23 times 436, well, if you do that out, you'll see that there's no simple way to get the correct number of significant figures. We need to have 2 because of the 23. We can't do that because of the 0 right here. So I switched it to scientific notation. Here we have another one. 3 significant figures divided by 2 significant figures. And even though there's a decimal point here, that doesn't make any impact at all. All we're paying attention to is significant figures. And so overall we had 2. Now, we also want to make sure that we know how to deal with this when we're doing more complex multi-step problems. So here I just have an example with some numbers to get the idea across. Let's say we have this problem. Now, if we look at the numerator and the denominator, we need to look at these separately first. A lot of people say, well, can't I just type everything into my calculator and then round at the end? Well, oftentimes this will work. And if you only have multiplication and division, that's fine because you're only going to be basing it on significant figures. When you start getting addition and subtraction, those things get a little bit more complex. So, for example, let's look at the top here. We have a tens place and a hundredths place. So when we go to figure that out, it's going to be to the tens place. The problem comes in that if you constantly are rounding things, you keep introducing a little bit of error each time you do that. So what we do is we hold out a number. Each time that we do a step, you hold at least one number out. Of course, if we are doing this in your calculator, oftentimes this will just involve a bunch of second enters. But if you're doing it by hand, you'll want to write this out. However, we need to keep track of which one is the last significant figure, and so what we do is we put a little underline. And in this form, you could actually hold out a couple past the significant figure if you wanted. You just need to do at least one. Now the bottom here, we have to the hundredths place and to the thousandths place. So when we go to round, it's going to be to the hundredths place. Since it's 0, you'll notice I didn't bother writing another 0 out. I could have, just to drive home the point that I didn't round that. I didn't make that error in rounding, or you can skip it because it's just a 0 and it's not significant. I had to write both of these zeros in though and underline this so that I knew how many significant figures there were. So now when I go to do the next step, I see that up here I have 3 significant figures, and down here I have 1, 2, 3, 4, 5 significant figures. So overall, I need to have 3 sig figs. And since in this imaginary problem, that is my answer, I can just leave it like this. If I needed to use this for another step, I would need to hold out another sig fig and underline here. But this is my answer, and so I go ahead and round that to my final 3 significant figures. Now, there's some other issues that we should discuss real quickly. That's what happens if we have conversion factors. So, for instance, there's 2 sort of divides here. We have metric conversion, integers, and definitions. So I have some examples of each of those here. If we're in a situation like this, we have infinite sig figs, because here we have 100 centimeters equals 1 meter. It's a definition. That is exactly how many centimeters are in a meter. It's not 100.0. It's not an accuracy issue. It's a definition. You'll see before too long we start doing things with energy levels, and we might say it happens at energy level 2. We need to fill that number in. That 2 is exactly 2. It is not about 2, it's not 2.0, it is exactly all the way 100% 2. And so it's infinite sig figs. Same sort of thing with 60 seconds in a minute. It's a definition, and so infinite number of sig figs. So whenever you're doing those, just go ahead and fill in the number, and then keep in mind that that's not going to define anything. If you have to put in 60 seconds equals 1 minute, that's not going to change your sig figs to 1. That doesn't touch your sig figs at all. Now, there's another situation where we actually do have to fill in numbers. So for instance, if I give you a problem where you need to take and say lambda over the speed of light, and I give you lambda, and I say that lambda is 2.0 times 10 to the negative 9th meters. Okay, so you fill this into here, and you look at C, and you say, okay, well, C has a lot of, I could look up C to a large number of significant figures. How accurate do I need to be? And the answer to that is as accurate as what the problem demands. So here I have lambda is equal to 2.01, which when we fill in the speed of light, we never want a number that we can fill in, a number that we could look up to a better number or a more accurate number to set the number of significant figures. So the typical rule of thumb is that you hold the constant that you're looking up one past the number. So here we have 3 significant figures. So when I go to fill in the speed of light, I'm going to fill in 4 significant figures. And then when I get my answer, I'm back down to 3 sig figs. So that's how you deal with constants where you can look this up. You could look up the speed of light to much more significant figures if you want, but it doesn't really make that big of a difference. You just want to hold it 1 significant figure extra. Or in the case of addition and subtraction, 1 place extra. So hopefully now you know how to figure out which numbers are significant, and you can also determine how to keep significant figures when you're carrying out addition, subtraction, multiplication, and division, and while dealing with constants.